Hey everybody, this is called Observing Optics. My name is Connor Swann. I work at Celo. I'm an engineer specializing in infrastructure, blockchain systems, Web 2, Web 3 divide. Here to talk to you about the deployment process / observability system that we've built at Celo as we're building the optics interchain bridge communication channel. This is what we're going to be talking about. Quick little mission statement from Celo. We're going to talk about the just kind of overarching structure of what optics is. We're going to talk a little bit about observability, observing distributed systems. We're going to talk a little bit about how do I run this and do I even want to. And we're going to look a little bit at the optics deployment itself. So without further ado, Celob's goal is to build a financial system with the conditions of prosperity for all. And optics really plugs into that by producing a simple, gas-efficient interoperability standard for cross-chain communication. There's a couple highlights of this. It's really gas-efficient, really cheap to operate. It provides a nice standard for building cross-chain applications. And it's very, comparatively simple to implement compared to other existing blockchain bridges. So how does optics work? Really at its core, it's a unidirectional communication channel between two blockchains, allowing arbitrary transfer of any sort of data. I like to think of it as like TCP, although as you'll see in a second, there's a lot of distinctions to be made here. But we're focusing on getting Celo plugged into as many different blockchains as possible, not limited to the ones that I've just mentioned here. So simply, you've got a home chain, you've got a relay or a replica chain, and the home commits messages to its home state, and the messages are relayed to the various replicas by a series of off-chain agents. These agents just kind of exist. We're going to talk about the individual ones, what they do. So this is like the way that I like to think about optics. We've got our Solidity engineers that are very talented, and they like to think about the complexities of all the stuff. At its simplest, you can kind of just think you've got a message. The message gets committed to the home chain. Agents happen, and then it appears on the relay chain, the replica chain. So we're going to kind of talk about the more advanced topics here. We've got the agents, we've got the home chain, and we've got the originator and the recipient xApp. xApp is xApp for cross-chain application. First, the originator xApp dispatches a message. It hits the home chain. You've got the updater that will then observe the new updates, attest to the fact that there exists a new update. There's a watcher that is kind of like Batman. He watches, makes sure that nothing bad happens, and if something bad, like fraud, for example, does happen, the updater is disincentivized to do so via a bond that they have to put up, and they will be slashed. From there, the relayer takes the signed updates, puts them on one or more various relay or replica chains, and from there, the processor manages the queue and forwards any messages to recipients. So this is a message-based protocol. It's not necessarily particular token transfer, although you can build a xApp that implements a token bridge. So there's a lot going on here. My job is to try to make this as simple as possible for the engineers that are working on the team. So that's obviously the topic of this presentation. So monitoring, this is a quote from one of my favorite monitoring presentations. It's a talk called, it's a conference called Monitorama in Portland. Monitoring is the action of observing and checking the behavior and outputs of a system. And the ability to do this over time obviously allows you to detect regressions, detect any sort of weirdness that's going on. So it may seem obvious, but if you don't have a system that allows you to do this, then you're kind of lost in the woods. So what kind of things can we monitor here? We've got the smart contract state, we've got the agent behavior itself, and really where I spend a lot of my time is focusing on the agent behavior. So we're looking at logs, we're looking at confirmed and dropped transactions. Obviously, this is a blockchain-based system, so all these agents are sending transactions all over the place. transaction latency at each agent. We want to be able to observe the message latency end to end. Obviously, this is a hugely important thing affected by gas prices, all sorts of different environmental conditions. And then obviously the internal call graph of the application. And then smart contract state. These are for all of you, this is probably a thing that's pretty obvious. Just understanding the different roots of the message Merkle tree at each particular spot. So tools in the toolbox for doing this. We're doing predominantly 100% logging in this. In this particular case, we've got a distributed tracing system currently being built right now with the goal of producing kind of overarching tracing across the entire system. Metrics, obviously, and going to be building a blockchain-aware monitoring agent that allows us to produce very similar sorts of things in context with the smart contracts. So I've got a little dashboard to show you guys. This is what we use at C Labs that allows us to detect bugs. So, like I mentioned, we've got various different kinds of agents. I'm just going to walk through them. We've got Kathy. We call her Kathy because she's chatty Kathy. Kathy is constantly sending messages between one or more blockchains, and we use this to basically just debug the fact that the optical channel works. As you can see, we've got dispatch transactions, confirmed transactions, and we can see in this particular case, the Kovan testnet's kind of a wasteland in terms of just all sorts of weirdness in terms of the mempool. So things get dropped all the time. The gas fees are all over the place. So in this particular case, I think what happened was execution reverted for some reason, probably due to gas of some kind. So this is an indicator for an engineer to dive in, figure out what's going on. Yeah. So confirmed transactions, dispatch transactions, all the errors show up. And then we've got an understanding of which parts of the agents themselves are producing logs. If we've got, for example, DNS errors, the particular portion that is doing DNS lookups will kind of spike here, and then that's an indicator that things are going on. The other thing that's useful for this dashboard is, that's why it's not working. Cool. Let's do this, 3 hours. My button's disappeared, so we're not going to talk about that. Next thing that we are going to talk about is the deployment process. Next thing we're going to talk about is the bugs. So we've detected a bunch of really interesting sort of weirdness with this system already. In particular, the Kovan stuff that I was talking about. A lot of the libraries are written with kind of Ethereum mainnet in mind. And you can kind of make some assumptions in mainnet that you can't necessarily make in a testnet environment. In particular, the fact that transactions will always eventually confirm. The Ether's Rust package was built to always check for transaction receipt, for example. And if the transaction receipt doesn't appear, then it'll just loop forever, and you'll get in a deadlock. James Presswich, our resident Rust wizard, sort of figured that out last week with the help of this dashboard. Optics bugs, bad update logic, general agent bugs, these things sort of appear on this dashboard in quick succession. We're pretty excited about the tracing project that we're working on right now. If you aren't familiar with what tracing is, if you open the network tab on your browser when you're loading a web page, there's a bunch of different requests that are going through, and having an understanding of when requests start, when request ends is, at least I view it as obviously important. We are mapping this sort of traditional Web 2 tooling to more Web 3 sort of context. We're building a distributed system. We've got a bunch of agents that are doing particular operations, and having an understanding of when these operations start and end and how they flow into each other is incredibly important. So there will be a blog post about that pretty soon. Stay tuned. A lot of people have been asking me, Connor, how do I run this? Do I want to run a bridge? And the answer is kind of. So the agent deployments they're all Docker containers. We run everything in Kubernetes. If you're familiar with Kubernetes, anybody? One, great, perfect. Kubernetes is a piece of infrastructure that's used to run Docker containers at scale. This is a thing that I, hold near and dear to my heart, and my coworkers hate it because, they don't like running it. So that's why I'm here. All of these smart contract deployments are just typical hard hat TypeScript sort of stuff. And if you're interested in this at all, there's a PR in our Optics monorepo to merge all this Helm fun stuff. Yeah. So do I even want to run this? The answer is probably not. You don't need to run an Optics bridge to get all the benefits. You probably just want to build a xApp. So if you're jonesing to run optical bridge, I'm happy to talk to you about it though. So yeah, the next and probably penultimate thing that I'm going to talk about here is just the current deployment that we have that's deployed between Kovan and Alpha Horus. Alpha Horus is the Celo testnet. Kovan is an Ethereum testnet. I've got a fun tool that gives me an interface into our Kubernetes cluster, and as we might be able to see here, we've got Alpha Horus home, and then we've got Kovan home. All of these, because I mentioned it's a unidirectional channel. To create a bidirectional channel between two blockchains, you set up a home on one, you set up a home on another, and then replicas on each. And as a result, you get a dual simplex channel between the two blockchains, and you can send messages bidirectionally. So that's exactly what we're doing. We've got Chatty Cathy on both sides, sending messages, and ultimately receiving the messages from both directions. Since not very many of you are familiar with Kubernetes, I'm not going to belabor the specifics here. We've got a series of pods, the ability to check the logs for each one. The logs get slurped up and then spit out into my dashboard for analysis. So what's next? The thing my team has been jonesing for a lot is the ability to change, for example, smart contract logic and have it automatically deployed. So my next big project is to get continuous deployment set up, redeploy our smart contract on code changes, redeploy our agents on code changes, and basically make this as seamless as possible. So everybody can just get to going building xApps. That was really quick. This has been a presentation about optics. I hope all of you learned something. Any questions about any of that? Yeah, go ahead.
So if I have an application deployed on mainnet on Celo, I would have to migrate my contracts over to optics, right?
No, not necessarily. Right now, we've got things deployed to testnet, just for the purposes of iterating and building the optical channel itself. Eventually, soon, at some point in the not so distant future, we'd love to have a channel deployed between Celo mainnet, Ethereum mainnet. So if you've got the applications already deployed to these networks, they should be compatible at some point in the future.
So then what are the xApps?
Yeah, so right now the xApp that's stuck in my head that I'm thinking about all the time is just a simple token bridge, burn, mint, burn. Because it's a message-based protocol, we can build any sort of app that requires interchain messaging. So, sky's kind of the limit. If you've got an idea, I'd love to talk about it, because even I don't really have a full understanding of the entire problem space when it comes to xApps. Going once?
Where'd you get that shirt from?
Where'd I get that shirt from? It's a brand called Teddy Fresh in the US. You can check it out. Got the matching Nikes too. Go ahead.
Can you dive a bit more into agents' incentives and like e-payments for users?
Yeah. So basically, the only incentivized agent right now that exists is the updater itself. Right now, it's everything is permissioned. So in order to be an updater, you have to be enrolled in the home and replicas, and the updater is bonded. So they'll have to put up a particular fee of some kind in order to be the updater itself. Because this is an optimistic system, all of the verification is done off-chain. And there's the special agent called the Watcher that will pull down all of the proofs that the updater is providing, and then verify them. And then if the proofs don't verify, then they basically commit an attestation back to the home chain saying, hey, something's fishy, and the optical channel will cut and obviously slash the updater. The goal in the future is to produce like a governance type process that will allow us to enroll a round robin style type of updater group.
So are you planning to have any kind of like forced errors to get watchers incentivized as well? Because the problem is that if no updater cheats any time, then the watcher never gets an opportunity to get some.
Yeah, I mean, basically we as the optics team are going to be operating sort of the entire bridge for the first one. And the goal is to produce a system of incentives that will allow us to decentralize it. I don't really think, I think right now the updater is the only one that's going to be planned to have any sort of incentive around it, because owners of xApps themselves will be running their own watcher because it's in their best interest to prevent any sort of fraud. So I think that's probably the incentive. It's less about the collecting fees as a watcher and more about protecting yourself and protecting your investment as the operator of a xApp. Cool. Yeah. Sweet. Go team.